try to understand the type of data your mic gets. So let us assume you have, let's say, a waveform. Okay, so this is the waveform emits from the environment or some sound. This waveform, what you usually do is, if you say something like always at first edge, let's say clock 10 Hz. Suppose you did that and you say begin, and you mention your LED is equal to mic in. So what happens is, it would actually take a value here. 10 Hz means 0.1 second. So 0.1 second later, it would take another value, for example here. Let us say 0.1 second. Let us say another 0.1 second is here. So it would take this value and it would display it on the LED. This is what this would do if ever you use this code. But your mic in actually can be updated up to 20 kHz. Okay? So your mic in, this one, the original signal, updates at 20 kHz. So what if you actually make use of all the signals that you get? In between, you are actually reading this signal. So in reality, your waveform is being read every 50 microseconds. 50 microseconds is 20 kilohertz. Okay, so every 50 microseconds, your mic in is being read. This is the highest speed. So let us say this is 50 microseconds. So if you want your LED to be updated at the fastest speed, usually you would use a clock of 20 kHz. If you use your assign LED is equal to mic in, it is updated at 20 kHz because the mic in is updated at 20 kHz. Okay? Some of you would say assign LED is equal to mic in. You will not be using an always block. But we like to use always block because whenever we have a synchronous system, we are able to control the system much better. That's why we tend to use clock. Clock allows us to control the system better. Okay? So if we use 20 kHz, what we will do is we will actually be reading this signal very often. So right now, what I want you to do is maybe try a 10 Hz clock. So instead of updating the LED based on mic in, now you will do something else. Now I actually want you to take this signal. Okay? So you take in your mic in value, let us say over here. Take in this mic in value, take in this mic in value, and this mic in value. You take these values, and what you need to do is you pass it through an algorithm. Okay. This is an algorithm. Later, I will call this algorithm as a peak algorithm. This is for later. For now, ignore this. What you do is you take the mic in signal, you directly send it to somewhere else, to another set of code, which will do the following. So this set of code here, okay, so we have our set of code. Inside, what I want you to do is to actually put each one of these values to light up a certain LED. I don't want a binary value because right now this is currently a binary value, maybe 1011, 1101, 1111. Okay? So some LEDs will be on and off. I don't want that. Instead, what I want to do is I want to tell it if you're within a certain range, a certain amount of LED will light up. So what you need to do is something as follows. Always at first edge, take a fast clock, maybe a clock of, let's say, 12.5 megahertz, just for example. Okay. Always at first edge of first clock, I want you to indicate a certain range where the LED will turn on. For example, you may say if mic in is greater than 2000 and mic in is less than 2500, maybe you can put an additional bracket to make sure you don't encounter logical errors later. Okay. Then maybe you want your LED to be a certain value. Okay. Maybe 0001. Okay. Then maybe you have an else if your mic in is a certain value, so mic in is greater than 2500, let's say it is less than 12. Okay, so and maybe your mic in 1, then you give it the next 6 bit, which is G, so 001100, and then maybe you give it a value like B, 11000, for example. So this is a 16-bit value in bits. If you give it this value, your next pixel will have a certain color. Okay, for simplicity, let me say everything is, let me just erase this. Okay. So let me say I erase this. Let me say my red is 00000, then my blue is 00000. And suppose my green is 110011. Okay? So my next pixel will actually be a bit green. Okay? Then whenever your pixel index, let's say your pixel index is currently giving you a value like 98. Okay? This is giving you a pixel value of 98. It means if here you are now giving it this green color, it means the pixel 99 is the one which will actually be green color. Okay, so it will tell you what is the current pixel index. You tell it what is the color of the next pixel. So for this stuff, just for simplicity and to test whether you're actually able to get the color on the screen, try the following codes. Okay? So you will say always. So let's have our always at first edge, a fast clock, a big clock like 12.5 megahertz. It has to be quite fast, more than 6.25, okay, at least 6.25. So let us say we have the following code, always at first edge. I want it to do the following. I will say if. Okay. Remember, each statement is inside an always block. So if my FixIndex, okay, so if my pixel index is greater than, let's say, 2500, and my FixIndex is less than 5000, maybe. Okay. If I have only one line of instruction, I don't need a begin and end, so I will just write maybe my OLED data is equal to a certain value. For example, let's give it this value. Let us say you give it 11100, and then green maybe off. Okay. Then maybe I want some blue. Okay. So if you tell it this, between 2500 and 5000, maybe it will be a bit purple. So let us say maybe your 2500 is here, maybe your 5000 is here. So all these pixels that we have here will actually be a bit purple in color. Okay? So you need an else condition. So in the else condition, this is compulsory. So in the else condition, put another color. Okay, don't put black, put another color to know that it is at least going to the else condition. So maybe you can try the color such as, if you want white, just put everything one, okay? Just for example. So you will have the following, and this is the starting point to test your OLED. Okay? So hopefully you will be able to have some color like this on the OLED screen. So I repeat, you are only concerned with my PixelIndex, so that's the index you're checking. Automatically the value is changing. So every time you are just checking what is the current value to tell it what is the next pixel data. Okay? So the next pixel data will be a certain color. Okay? So every time it will give you a pixel, you tell it the next pixel what is the color. And it is done using this set of code. So for a starting point, you try the following. Okay? So both the mic has a starting point, which is for the mic you will have this if condition and some range. Remember, debugging means do not write many if conditions in one go. Just write one if and one else, just like the OLED, if and else. I know many cases, many of you tend to read codes with lots of if, and then you say it's not working. This is not easy to debug. Always have just two conditions, the simplest one, to see if something works. Okay? If it works, then you try more conditions. Okay? So try this for the OLED, try that for the mic in, and then in the next briefing, I will expand on it so that it is easier to program on the OLED, and so that you know about the peak algorithms that I'm talking about here. Okay? So go on and get started with this. If you have already done this, that's very good. Just proceed on, and you can just try to complete all the requirements here if you have already done this part. Okay? So next briefing will be in about 1 hour. Okay, so meanwhile, 2,500, just say it is less than 12. Okay, so and maybe your mic in is less than or equal to 3,000. Maybe your LED is given another value, for example, 0011. Okay, so I want you to do that up to a certain value. The value that you need to choose is, I will just tell you for now, the minimum is 2048, the maximum is 4095. Okay? So you will, anything below 2048, you can assume it's 0. Okay? It's a negative part of the wave which we ignore. We actually push the wave up. Okay? So that's why we only look at the upper half. So yeah, in terms of digital design, you only need to worry about 2048 until 4095. Okay? So try to make your LED lighter based on some range. Alright? So this code, when you write this code, at the very beginning, just write 2 or 3 conditions. Don't go and write all 16 conditions. It will be extremely difficult to debug. Okay? So you may even try if and then else. If it works, then you put the else if, another else. And if it works, then you complete everything. Alright? So this is what you start doing at the beginning right now. Then later I will talk about the peak algorithm. Okay? So this is how you read your waveform. This is for the mic. Now let me talk for the OLED so that you know what the OLED can do. Alright? Actually, this part you can do it within 1 to 2 hours. If you have your knowledge from your previous stuff, it is just 1 to 2 hours. Okay? So, how about the OLED? So to help you get started, let's look at the OLED. The OLED is actually as simple as a mic. So you will have your OLED. Let's see, last week. Okay. So we mentioned that the OLED is concerned only with the PixelIndex and the OLED data. So once again here, let us say we have our OLED. So here, this is our OLED. Yeah. Let us say we have this OLED over here. This OLED has a certain index. Okay, so your OLED has index 0 to 95 and then 0 to 63. Okay, so this is a 96 by 64 OLED display. Right? Then you know your OLED display.v, which is a set of code which has already been given to you. OLED display.v. It has many connections. For example, you have already enabled the connection last week. So now that you have enabled the connections and made all the other connections, you are only concerned with two signals. You don't care what is inside. You don't care about the other signals. You only care about these two things. The first thing is a 13-bit data, which is a pixel index, okay, and a certain input, which is a 16-bit data, for example, my OLED data. These are the only two things you actually need. So how do you actually draw something on the screen? So what happens is, on the screen you have many pixels. This is pixel 0, this is pixel 1, this is pixel 2, pixel 3, etc. Okay? So if you go on, it will go up to pixel 95. Then the next line is pixel 96, pixel 97, pixel 98, etc. It goes all the way till here. Okay, so this pixel, the value is calculated 96 times 64, 6143. Okay, so it goes up to 6143 because this is 6144. Since we start at 0, it is 6143. So this is pixel index 6143. So actually, this OLED display.v is automatically updating this pixel index. This pixel index that you have here will be a value from 0 to 6143. Okay? This is automatically implemented by the OLED display.v. You do not need to create a counter for that. So automatically implemented by OLED display.v. Okay. So your task is to actually read the pixel index and then say what color the next pixel should be. So what is happening is, if, for example, my pixel index is equal to 0, okay, pixel index is 0, and you as a user for OLED data, you give it this value. Let's say you give it a certain value like maybe another pixel index 5000, maybe that one has a certain x coordinates, maybe 60, and then this one maybe has, let's say, 40. Okay, let us say, so this coordinate is 60, 40. This x and y coordinate is 30, 20. So what you need to do now is, instead of checking pixel index value, what you do is you take this pixel index. Okay, so this is your pixel index. You actually send this to another module, the pixel index. You send it to a module which converts your pixel index to x and y coordinates. Okay. So the value here is just a 13-bit value. Why is it 13? Because 13 allows you to count from 0 to 8191. Okay. So this is a 13-bit value, but your pixel index is from 0 to 6143. Okay, so basically 13-bit can fit the 0 to 6143. So you take in the pixel index. Inside, you will write 1, 2, or 3 lines of code around there, and it will provide to you a certain output, x, of a certain size, you need to be able to store up to 95. So figure out how many bits you need to store 95. And it will provide you a value of y, 10 bits. So figure out how many bits you need to store up to a value of 63. Okay? So the output is x and y given a certain pixel index. In other words, if you want to draw this same thing, this time you no longer use a pixel index, instead you use an x and y. So the code will change as follows. Instead of using this, what will happen is you will say if x is, let's say, greater than, let's say, 30. Is it 30? Did I choose 30? Yeah, 30 to 60. So if x is greater than 30 and maybe x is less than 60 and maybe y is greater than 20 and maybe y is less than 40, then I want my OLED data to be this. So now you are going to use x and y coordinates. Do not use PixelIndex, it will be very difficult to create pictures. But if you have x and y coordinate, it is easier to create a picture. Okay? So this is why here we are asking you to actually convert it to x and y coordinates just by using your simple modulo operator and division operator inside. Okay? Some value here, modulo with a value here, modulo another value. Then you get your x and y. Okay, one is for x, one is for y. So PixelIndex modulo something, PixelIndex divided by something, you will get your x and y. Okay. So this is what is required first, meaning convert the PixelIndex to the x and y coordinate, which is this thing that we are giving you here. Work on creating x and y coordinate. Okay. So then you will be able to use x and y. And then once you have this, all these are easier to complete. So what are the tasks? Create a white border. So not a big issue. We're just asking you to create this border. Quite easy. X greater than a certain value and x less than a certain value and y is equal to, for example, 0. You get this line. Okay? Similarly, you can draw this line and this line. Okay? It's just some coordinates like what you have here. Okay? So this is a thin border, but you're also told to create a 3 pixel. Okay? 3 pixel means you will just have 3 lines, so the border appears thicker. Okay? 3 lines next to each other, so it will be a thicker border. So the user must be able to get a thicker border either by using a switch or push button. Here we are more flexible, like just here also. We don't tell you what push button or what switches to use, you're free to choose. Similarly, you're free to choose which segments you want to use for L or for the values. Okay, so there are flexibility here. So here we have our border, quite easily done. One complementary color means just choose another color. For example, here we say over here, as the background is this color. Well, another theme is maybe the background is another color. Okay? So you can use a register here, or you can use a switch to tell it what the OLED data should be. So this is one color theme, another color theme will change the background. Okay? So here you would have the other color theme. But the color theme must not only change the background, it must also change this color. For example, you can choose red, purple, and pink, for example. That kind of, I don't know whether it looks nice or not, but as long as it's easy on the user's eyes, you will accept it. Okay? So there are no limitations here. Some of you will choose light blue, darkest blue, for example. Okay? Some of you will choose a gradient color. For example, rainbow color. Some of you will choose very light blue, slightly less light blue, slightly lesser, etc. So all these are open to you. Okay? It's just one complementary color. So that complementary color, you can change it by just pressing a push button or turning on a switch. Okay? So the background color should change, the border color should change, and the volume bar color should change. Okay? So background, border, volume bar. Okay, so this is a border, this is a volume bar. So if the three colors change, then you have met this condition. Implement a function to turn off specific part of the display. So we need a switch or push button to turn off the border, turn off the volume bar, turn off other components. So what does this mean? Turning off the border is straightforward. You can just paint it to be black, same as the background, it will just turn it off. Okay? Turning off the volume bar also is straightforward, just paint it black, as if it's turned off. Okay? So we request you to do this at least using the default background color, okay? At least black. If you can do it for other background color, it also can be considered as an improvement. Okay? Showing hiding other components, it means if ever you have, for example, text on your display, text is optional. Okay? Text means you have to do pixel by pixel here. So if you want to hide the text, you can hide it. Some of you may have other things on the screen. For example, you may have a menu system, you may have maybe a circle doing something, etc. So if you want to hide it, you should be able to hide it. Okay? So this is what we mean by other component, meaning other things that you have added on the screen. Some of you may want to put an XY axis for a reason I don't know, but we should be able to hide it. Right? So this is what we mean by other components. Finally, move the volume bar left or right using switches or push button. So maybe if you use the left push button, maybe the volume bar appears here. If you use the right one, maybe it appears here. Or you can use just a switch or two switches which can make it move here or move here. Okay? So it's just to make this volume bar appear at a different place. Some of you may make it appear as a corner so that you have more space for other things here. Okay? So this is OLED, and this is what student B will be working on. So when you work on this, assume that your team member is giving you a certain volume. For example, if your team member is giving you a volume of, let's say, 7, then it must show 3, 4, 5, 6, 7, at least these boxes. Okay? If you assume your team member is giving you a volume of 10, then it must show, for example, 10 boxes. Okay? This is when you are working independently on this system. Then, later, you will combine it with your team member such that this is a variable. Then you will see the volume bar moves up and down. Okay? It will match the LED. For example, if 5 LEDs are on, we will have 5 boxes here. Okay? If 7 LEDs are on, we will have 7 boxes. So here, we give you the choice to decide how much is green, how much is yellow, how much is red, what's the width, what's the distance in between, it's all up to you. Okay? There are flexibility here, as long as you can see a volume bar. Okay? So this is for the OLED display. So like I said here, some of you will complete it within 1.5 days, others will take more. It just needs a lot of your logical and logical or know when to use if, else if, etc. Okay? So you do these two tasks independently, and hopefully, once you have completed this task, your friend has completed this, then you can combine it over the next few days. Okay? So this is a requirement for student A and student B. In my last briefing, in 20 minutes or so, I will show you an example of what your previous classmates from previous semesters have done. At least you have an idea of what they can accomplish within 17 days. Okay? So you have already used up like 60 days learning about Verilog. Now you have 17 days to apply everything you learned. Okay? So, alright, so with that, I think I covered all of this. I hope you won't have much difficulty. So if you still have doubts regarding the requirement, please let me know. Okay? So the next briefing will be in about 20 minutes time. Just a demonstration of past semesters projects. Okay, thanks. Synchronize the notebook so you can have a look at it. Okay, so this is my notebook.
是